Hello, Ben Rabbit here. Today I'm trying a different kind of video, and there was a special reason for this, and it was because yesterday OpenAI launched a new model, or you can call it a new product in their offers, and it is O1 preview, which would be the first version, the first one of the Orion models, the Orion series of models, which itself is part of the Project Strawberry. Project Strawberry, which was rumored to be the Q-star technique, and that's an interesting point to start because that is where we get the hints for what is new that comes into one, because the rumors of Q-star, like if you break down what that name means in the context of computer science, I think I should say, is a combination of Q-learning, which is a reinforcement learning technique. And in reinforcement learning, you have a situation you imagine an agent that interacts with the environment, and then it receives feedbacks that then it can use to inform its action back into the environment. And then that cycle continues over and over, and that's a paradigm, a way to, an approach to machine learning that may or may not use neural networks, may or may not use deep neural networks. Like when it does, it's sometimes called deep reinforcement learning, right? And that's one point that I would like to stress out, because I've just seen one video from 2 Million Papers, which is a channel that I follow, that I admire, and it seems to have a little misleading statement about this, because he said, the host of the channel said that for the first time we were joining together reinforcement learning with neural networks, which clearly isn't the case, because you have many other instances of using deep neural networks together with, sorry, there's no noise around, but together with the noise maybe lost where I was at MacTalk. So it isn't the first time that neural networks or deep neural networks are mixed with reinforcement learning. There were many previous instances of that. Like if you think of many of those big achievements that involve reinforcement learning, they involve neural networks. So, but what does it come to help here? Because you can imagine a situation that you are trying to solve that now isn't in a closed domain, like a game of chess or Mario or something similar to that. Now you can have a more open domain of what you're trying to achieve, which is expressed by language, and then you can explore the possibilities, and then traverse the best route for achieving your goals. So in theory, that's what it would be. Like we don't have a clear explanation about how one works, and that's intentional. They use only the cryptic words for what it is, and here it talks about the results that it's able to achieve, about the safety measures that they've taken while training and deploying this tool or model, and then they direct who would benefit from that, from using O1 or O1 preview. And schooling, math, and similar things, basically specific problem solving. And one important thing is that this model is much more expensive to use than the others, and if you are using directly ChatGPT, that translates to a tighter limit of how many times you can use it. Like, and if there are weekly limits, it means if you run out of the limits, that will be started in the next week, not in the next day, as we are used to in other models. And here they have examples. Of course, coding is the place I would like to use one. And more on that on a bit of time. I will come back to that. So let me use the carousel here. Combination. It's really a big launch they have. I was looking for the coding example that they have. See, because we are look at this.
Yeah, let's maybe demo again, right? Can we like implement like a small game?
I don't want the sound for now, but look at it. What is their example for showcasing the capabilities of one? Writing a snake game. But you have to think about that. If you have something that is already done by humans many times, that will appear on the training data for the base language model, the base transformer model, and then it will be approximately memorizing the solution. Like a very rough and layman way to describe what this new wave of generative AI does. It's not precise, but it's a quick way to try to understand is that it would work like a compression algorithm, that it would get the data, it would compress into a smaller file, and then that's the interesting point. And then the creation, the generation happens at the decompressing of that file. That means that because it has a lossy compression, that means it's lost some information when compressing. When you give it what would be equivalent of a hash key, would be your prompt, the decompression would be something new. Let's say if you try to understand what machine learning does, some interpolation, that's where it will be filling the gaps into the data. If you want to imagine the data into an hyperspace, because it isn't 3D, it's very high dimensional. If you try to visualize the space of data that you are passing the model, it will try to fill the gaps into that hyperspace, and that would be, you can imagine the space of your outputs, which of course is a huge space to traverse. And then the reasoning concept, the Q-star concept, the idea of, okay, we have another good example. Let's see.
I want to show an example of a.
Let me see what this one does before finishing that idea. Sorry, that can be annoying for someone who sees this video. Square for 5. No, this is better. If he is trying to make something that wasn't previous existing, that's more interesting. Because what does this reasoning idea, that Q-star idea, that's cosmic learning, mixing, well, there's one more concept that should maybe mention this, that it would be like given not from the Q-star rules exactly, I guess, but from what you will see now in this release. There's one more concept, which is inference time, which is the chain of thoughts prompting. It will self-prompt many steps before giving a final answer. Like it would try to break down the tasks, and it's lovely having the strawberries there, and that should be useful. That kind of space exploration by the reinforcement learning, especially the cosmic learning, that would be useful to new tasks, to things that you didn't see before, to try to go beyond the simple interpolation that the base model would do. You'd like to go further into the space of ideas. You would like to stumble in the hallucination, stumble in what of those ideas are wrong, the ideas that you generated with the base models. You'd like to stumble in the problems and correct the problems. So ideally, if you're thinking in terms of coding, in that reinforcement learning, you would run the code, you would test the code to see what is wrong and what is right in what you did, to make it equivalent to playing a game. And then the chain of thought prompting will give you the chance to further self-correct, because sometimes if you ask the model, are you sure about what you did, or to try again, and things like that, then that you would correct its sensor. And one final thing that I would like to say is that I run some experiments with the model, those are private experiments. As I mentioned, it's an expensive model and you have to think carefully what you will use it for. And so I've used it for coding, but not for the kind of thing that I would make public. And so that's why I want to do a live coding and include it in the video, because it has to have some specific applications. For now, what I have is for purposes that can't be fully shared. But maybe someday I have some application that I can share here for everyone. And the thing is, while I was trying to use that model for that specific hard coding purpose, it didn't actually solve the problem. But I still think this model goes for beyond what others can do. So it's like it would have a thin sliver of applications where it would have the edge. So that's one thing to be concerned about for someone who is willing to pay for this model. You have to plan your usage. You have to use other models for most tasks, and when it's really necessary, use it. And maybe you have even to use some cognitive architecture externally to want to fully benefit from what it can achieve, because it may not be obvious to prompt it to have a good answer in a few shots. Your problem may be harder than it's prepared for at first, and you have to help it in a way. Yeah, it's very interesting. It can be very useful. Like that idea of using those concepts determination can make it explore the tasks the problems that you have daily in a way that goes further, that goes beyond the training space. But unfortunately, so far not that further beyond, not that easy. So that's it for this video. Hope it was a fun first experience.
This is one of my favorite puzzles that I
I have one final observation that it's shown here that it's an example one question that was famous for being used as a benchmark for by a famous AI YouTuber, and he was super happy that this question was used. Like it's suspicious, like if you are using it for something that was already widely tested, widely done, it may be the case that it was trained to solve that question, even though they changed the little, they changed the word. It was marble and then replaced it by strawberry in a very fun way. But that's it. The focus, when you're talking about the machine learning general, is performance on the test cases that are new things, not your training data. Performing especially well, especially when the training data is called overfitting, is something that you don't decide machine learning general. So with that, I finished the video. Hope you guys like it. See you next time.